Mini lesson 3A, formulate and solve exponential and logarithmic equations. Common ratio given 2 points. B equals f of t2 over f of t1 raised to the 1 over t2 minus t1 power. Converting f of t equals a b to the t power to f of t a e to the kt power. To do this, you want first let b equal e to the k power, and then solve for k. And then you get k equals ln of b. To get rid of an e, you would natural log each side. Using the power rule, we could move the k to the front, and ln of e is just 1. Let's look at an application. Izzy performs an experiment to investigate how quickly a certain strain of bacteria reproduces in a controlled environment. He places 10 bacteria colonies in a petri dish at the start of the experiment, which he identifies as day 0. On day 3 of the experiment, he observes that there are 20 bacteria colonies in the petri dish. He predicts that if the bacteria growth continues with the same growth factor, then there should be 40 bacteria colonies on day 6. Assuming that the bacteria grow continuously, write an exponential function of the form f of t equals a e to kt power to model the number of bacteria colonies in the petri dish after t days. Then, use the function to estimate the number of bacteria colonies to the nearest whole number in the petri dish on day 7 and on day 28 of the experiment. Explain your reasoning. We want to identify 2 points in this scenario. We have day 0 with 10 bacteria and day 3 with 20 bacteria. We're going to use these 2 points to find the common ratio. We have T1 and f of T1, and then we have T2 and f of T2. Using the formula from above, we're going to plug these in. (20 over 10 raised to the 1 over 3 minus 0 power is going to equal 20 divided by 10 is 2, and 3 minus 0 is just 3. Alright, so we can identify the initial population. On day 0, there was 10 bacteria, so A equals 10. Let's write our function. A times b to the t power is going to be 10 times 2 to the 1/3 power raised to the t power. And you could rewrite that as 10 times 2 to the t over 3 power. To solve for k, we're going to let b equal our 2 to the 1/3 power, and that's going to equal e to the k. Take the natural log of each side, and so k equals ln of 2 to the 1/3 power, which is 1/3 ln of 2, and we can approximate that to get 0.231. Let's rewrite this in this form. We have a e to the kt power is 10 e to the 0.231 t. If we plug in 7 into this formula, we get this. And if we put that in the calculator, we'll get approximately 50. And then let's plug in 28 into the formula. $6,451. On this next page, we're going to focus on the verbal and algebraic steps for solving various parts of this exponential equation. Y equals A times e to the kt power. In general, we have the formula. To solve for t, we're going to divide by the a value. So on our numerical example, 3 equals 50 e to the 0.12 t, we're going to divide by 50 on each side of the equation. And then we have 3 over 50 equals e to the 0.12 t power. For the next step, we're going to take the natural log of each side to get rid of the e. Then we have ln of 3 over 50 equals ln of e to the 0.12 t. We have the property that ln e equals 1. So we can rewrite this as ln of 3 over 50 equals 0.12 times t. Lastly, we're going to divide each side by that k value, which in this case is 0.12. And then we write out our final solution. ln of 3 over 50 divided by 0.12 equals t. And if they want you to approximate that, you would type that into the calculator. Let's use the same equation, but this time we're going to solve for k. First, we're given the equation. In this case, we have 7 equals 40e to the k times 9 power. Divide each side by your a term. We're going to divide each side by 40. And then we get 7 over 40 equals e to the k times 9 power. Next, we'll take the natural log of each side to get rid of that e. We rewrite it. ln of 7 over 40 equals ln of e to the k times 9 power. We have our property ln e equals 1, so we can rewrite this as ln of 7 over 40 equals k times 9. And then lastly, we're going to divide each side by t. In this case, it's 9. And we could write our final answer as ln of 7 over 40 divided by 9 equals k. This time we'll solve for a. Notice there are less steps. We have our given, and then we're going to divide each side by everything that's not the a. So the e to the kt power on both sides. In this case, it's e to the 0.5 times 20 power. And then we can rewrite our answer as 16 over e to the 0.5 times 20 power equals a. On the last one, we're evaluating for the y value. In this case, there's no solving at all. You would just write out the expression and plug it into the calculator if you want to approximate it. All right, on this next page, we're going to be solving for various parts of the logarithmic equation m equals log b of I over s. Let's solve for I first. We're given our equation, in this case 9.5 equals log 10 of I over 3. We're going to base each side by b. That gets the log and b and the b to cancel on this side of the equation. In this case, we're going to base each side by 10. Rewrite the equation. 10 to the 9.5 power equals 10 to the log base 10 of I over 3. We have the property b to the log b of I over s is equal to just I over s. These are going to cancel. And we're left with 10 to the 9.5 power equals I over 3. The last step is to multiply by s. In this case, it's 3. And then we can rewrite our final answer. 3 times 10 to the 9.5 power equals I. Let's solve for s on this one. We're given the equation 6 equals log 2 of 7 over s. We're going to base each side by b, which is 2, and rewrite it. We have 2 to the 6th power equals 2 to the log 2 of 7 over s. And the log and the base cancel. We can rewrite it as 2 to the 6th power equals 7 over s. Multiply each side by s. And then we'll get s times 2 to the 6th power equals 7. And then the last step, divide each side by b to the m power. Which is 2 to the 6th power. S equals 7 over 2 to the 6th power. Let's solve for b. We're given our equation 7.5 equals log b of 8 over 5. First, base each side by b. So we're going to base each side by that b. And rewrite it. B to 7.5 power equals b to the log b of 8 over 5 right here. Next, we know that the base and the log cancel. B to 7.5 power equals 8 over 5. You will exponentiate each side by the reciprocal of that exponent. In this case, we're going to exponentiate each side by 1 over 7.5. By the power over power rule, these are going to cancel out. And you're left with B equals 8 over 5 to the 1 over 7.5 power. And then the last one, if we're looking for M, we're just evaluating the expression. No solving needed. You would just plug this into the calculator if you wanted to approximate it.